We do have formulas for the derivatives of inverse trig functions, but we derive them using implicit differentiation. So I'm going to go ahead and show you where these formulas came from, and then you're going to want to make sure that you put those in your tool belt so you don't have to derive them every time. So remember, this was the original equation. So if I'm trying to find the derivative, I can go ahead and use implicit by saying that this is going to be sine of y is equal to x. And I know how to derive sine, but now I'm implicit. So now there's going to be a dy dx involved. So let's go ahead and take the derivative. So the derivative of sine of y is going to be cosine of y, but the derivative of y is dy dx. That's ultimately what I'm solving for here. And the derivative of x is dx dx, which is 1. So if I solve for dy dx, I end up with 1 divided by cosine of y. Now let's go back to basically what we did in the previous examples and build a triangle that has a reference angle to it. So if I have a reference triangle here, I should be able to figure out what cosine of y was. So when I have this set up, y equals arc sine of x. Remember, x would represent the, whole thing represents the angle, and x represents the ratio. So if x is the ratio of sine, it would be x over 1. Well, I can go ahead and find this adjacent piece by using Pythagorean theorem. So that would be 1 minus x squared. Obviously, the square root is there as well. So when I do cosine of y, I'm asking for cosine of this angle. That's the angle piece. So this would end up being 1 divided by cosine of y, or you can rewrite that as secant. And secant of y is going to be the hypotenuse, which is 1, over the adjacent, which is square root of 1 minus x squared. So this is going to be 1 over the square root of 1 minus x squared. That is going to be your dy dx. So your derivative here, it doesn't have, you'll notice it doesn't have any trig in it, right? So this isn't the derivative of sine as cosine anymore. This is a completely different situation where we're just looking at our values. So let's go ahead and do another one. We've got arc tan. So same scenario. We're going to rewrite this as tangent of y is equal to x. And now I know how to take the derivative of tangent. So the derivative here, this is all implicit in nature. The derivative here is going to be secant squared of y times dy dx is equal to 1. I would divide both sides by secant squared, and I would get dy dx is equal to 1 divided by secant squared of y. I could also rewrite that as cosine squared of y. Now I do need a reference angle. I need to make sure that I know what these ratios are. So when I draw my reference angle, I'm going to take a look at the fact that the tangent of something, some angle, right, tangent of y, was equal to x. So this is going to be x and this is going to be 1. So when I use Pythagorean theorem, I get the square root of x squared plus 1. So when I plug in, I'm doing cosine. Cosine is 1 over the square root of x squared plus 1. So this is going to be the 1 over the square root of x squared plus 1. But remember, it's all squared because it was cosine of y squared. Well, 1 squared is still just 1. But when I square the bottom, the square root goes away, and there is your dy dx. These are all building formulas, remember? So keep that in mind. Then I've got one more. I need arc secant. There's going to be a relationship between the sine, tangent, and secant with cosine, cotangent, and cosecant, so I'm not going to have to build all 6 of these. Let's go ahead and do the same thing. We'll set it up as secant of y is going to be equal to x, and now I'm going to take my derivative. The derivative of secant is secant tangent, so we would do secant y tangent y. This is going to be a little bit messier, it looks like. Oh, forgot my dy dx. Times dy dx, derivative of the inside, it is implicit, equals 1. And then I want to divide, so I have dy dx equals 1 over secant of y tangent of y. If you wanted to rewrite that, 1 over secant is cosine of y, and then 1 over tangent is cotangent of y. You don't have to do that, but obviously if you don't, you're going to be dealing with complex fraction that you're going to have to clean up a little bit. I need a reference angle, a reference triangle of sorts. So I'll set this up here. So my angle was y. That is my original y. And then secant, the ratio, was x. Remember, secant is hypotenuse over adjacent. So it should have been x over 1. So this is going to be the square root of x squared minus 1. Now it's important here that you recognize that this x is a hypotenuse. It's going to come into play in just a second. So let's go ahead and set this up. Cosine of y, I've got dy dx. So the cosine is going to be 1 over x. Right? And then the cotangent is going to be 1 over the square root of x squared minus 1. That's your cotangent. It's the adjacent over the opposite. Now, this is where I want to pay attention. This guy right here is a hypotenuse. Because it is a hypotenuse, no matter what quadrant I land in, it's always going to be positive. So we have to put absolute value signs around that x because it is a hypotenuse. Okay, it's representative of the hypotenuse. Okay, therefore always positive. That x is never going to give me a negative value. So that's going to be part of our formula when we build this. So dy dx, the simplest version, is going to be 1 over the absolute value of x times the square root of x squared minus 1. That's going to be your dy dx for secant. So as far as the formulas go, this is what they look like. Obviously, I don't have to just have x, right? I could have something else in there besides x. It's going to be the 1 over the square root of 1 minus u squared, and because it's a chain rule, we're always going to multiply by du dx. And then tangent is going to be 1 plus. There is no square root on that one. Go back and look at how we built the implicit. So you'll see this. This is 1 plus, or excuse me, x squared plus 1, right? So 1 plus u squared. And then this is going to be the square root of 1 minus x squared. Here's the square root of 1 minus u squared. So we've built all of these formulas. And this is going to be 1 over the absolute value of u, the square root of u squared minus 1. So you'll notice that the s ones, right, they have subtraction in them. And then tangent, I always think about that t being a plus sign. Right? And because this is a plus, this is the only one that doesn't have a root on it. The order of subtraction matters, so we have to be really careful with this. But these two u's always have to be right next to each other. Right? So I'm not going to put a u on the outside of sign. That's not going to help me. So these all look very similar to each other, and it is difficult, but we do want to memorize those. And of course, I need to multiply by the du dx. And then basically, we're just going to see the negative, right? So when I see the negative, this is going to be a negative 1 over the square root of 1 minus u squared times du dx. This is going to be a negative 1 over 1 plus u squared times du dx. This is going to be a negative 1 over the absolute value of u square root of u squared minus 1 times du dx. So if you can memorize these three on this side, then the cosine, cotangent, and cosecant are just going to be the negative versions of those formulas.